Okay, 11 a.m. I just came on here to review that last quiz we did to make sure everyone's online. David Roy, yay, David. David showed. I don't expect a lot of people here today, but I'm going to review the quiz and then post it up online there so everyone's got that in their pocket. And if you have any questions, let me know. I don't know if I can see the chat from here when I start. Let's turn the chat on, see if I can't see it. Okay, so there's chat. All right, so I'm going to go ahead and start. I guess we are recording. Oh, Isabella. Hello, Isabella.
Hello, how are you?
Good, good. All right, so I'm going to go ahead and start this review. Have any questions, shout them out, please. I'm looking at the chat, but I don't know if I'm going to be able to see that later. We'll see. Starting my share. Okay. Preview quiz. Let's start this quiz. Rock and roll. Okay. Question 1. MYC is a transcription factor that activates the production of cyclin D when it's paired with. So there's two things it pairs with. One is MIS1 and the other is MAX. And MAX is the one that's going to get you cyclin D. MIS1 inhibits the CDKIs. Let's pull that up real quick. As long as we're here, not there. So biology. MYC, beautiful MYC. Here we are. There. MYC and MAX gives us D2 and cyclin D, and also COL1. MIS and MYC and MIS will get us the CDKIs. Okay. Which of the following caspase is an executioner? Really, the only executioner we talked about was number 3. 8 is associated with the external, it's the initiator caspase associated with the extrinsic pathway. 9 is with the intrinsic pathway, and 7 we didn't talk about. This protein is part of the extrinsic pathway, Fas-associated death domain. Fas is the receptor. Fas ligand is the ligand, obviously. This is a kinase that phosphorylates P53. That would be check 1. If you remember that pathway, ATM senses the DNA damage, and then it activates check 1, and check 1 then phosphorylates P53, protecting it from MDM2. Which of the following is anti-apoptotic BCL2? Anti is this one. So we only talked about 2 anti-apoptotics. One is BCL2 and the other is BCL-XL. I think this X needs to be capitalized, but that's neither here nor there. What are the proteins involved in cell cycle activation by RTKs? Oh boy, this sounds exciting. Okay, what are the proteins involved in RTKs? Let's start here. RTK, and then grab SOS, RAS, RAF, MEC, MEC. It's number 5. MAP kinase would be 6. All right, what does MAP kinase do now? It's going to activate AP1. We're left with CD4, RB, MYC, cyclin E. So MYC is going to be an IEG. So let's put that one next and see what happens. And then MYC will cause the production of cyclin E, no doubt. Let's go with that. That number 8. And Ooh. Oh, wow. This is a hard one. I don't know, man. Let's go 9. I definitely want RB to be 10, but maybe I'll put this one as 8. This is a tough one. I don't know. I might get that one wrong. That's embarrassing. Okay.
I got that one wrong. I switched 8 and 10 on this question.
Yeah.
I switched RB and Cyclin E.
I think there was a picture that was supposed to be, yeah, this is where 2 points. There was a figure that was supposed to be part of this that is not. Let me show you that figure. That's the problem. You told me I could put a figure up, but you didn't do it. Where is it? Where is it? Where is it? This is it. Although I adapted it. Oh, you can't really see this because it's black. Get out of here. I adapted it for this exam. I think this is it. So with this, it's a little bit easier because it's telling you this is number that, you know? Yeah, that's a shitty question because you weren't allowed to see the figure. You really needed that. Is this the one I used? No. All right, I think I'm gonna go through and give everyone full credit for that question because it didn't show up the way it was supposed to. And it's hard to do this way. I mean, the first half of it you can do this way, but once you get down into the IEGs and DEGs, it doesn't really make a lot of sense. So I'm gonna go through and fix that. Okay, what is the order of events in the intrinsic pathway? Ooh, intrinsic. Loss of trophic factors is what kicks it off. That causes formation. This is going to be last. Let's put this guy last already. This is going to be second to last. Release of cytochrome C is going to happen before this. Buildup of pro-apoptotics. That's next. 2, 3, 4, and 5. Okay, loss of trophic factors, buildup of pro-apoptotic BCL2s, inhibition of BCL2, formation of apoptosome. Really, oh, nope. Oh, I messed that one up. Release of cytochrome C, formation of apoptosome, activation of 9, activation of 3. That should do her. Which of these is associated with opening the chromatin to allow access to genes? This is histone acetylase and histone deacetylase. So they're going to open up when they're acetylated. So we're going to have this one opening the chromatin. TGF beta binds, represses MYC when the SMADs bind to, I believe it's MIS1, nope, E2F. I'm going to look that one up real quick. Oops, not that one. Here's TGF beta binds to E2F. SMAD3 binds to E2F. Is that it? There's only 9. Oh yeah, there's only 9 questions because one was worth 2. And submit quiz. Let's see how I did. I know I screwed at least one up. Yeah, I got 96%. And this is the one I messed up. RB and cyclin E. Yeah, in the figure, it was pointing to it, so you couldn't really mess it up that easily. So, all right, I'll go through and give everyone credit for that. Okay, that's it for the quiz. Let's go back to our meetings. So, anybody have any questions? Let's stop.
I had a question on the intrinsic pathway.
Okay.
So there's a buildup of the pro-apoptotic BCL2 proteins, and then there's inhibition of BCL2. Can you just explain that again? Because I think I'm confusing myself.
Yeah, sure. Just to warn you, we're going to go into a lot more detail of BCL2s in the next chapter. But just in general, what you want to think is like when, just backing up a little bit, when you activate signal transduction, you tend to inhibit those factors. Remember, BAD was being phosphorylated by AKT and being inhibited. So what happens here is when you turn off those pathways, you're no longer inhibiting the pro-apoptotic BCL2s. And as we'll see in the next chapter, when these bind to the anti-apoptotic ones, they inhibit their activity, and they actually end up causing a channel to form from back and backs. We'll talk about it in the next chapter. But bottom line is, when you stop the signal transduction pathways, pro-apoptotics build up, they inhibit the anti-apoptotics, and then cytochrome C comes out. Does that make sense?
Okay, that makes sense. Yeah, thank you.
Let me show you, just this is what I've been working on, what we're going to talk about next Monday. Here's these pro-apoptotic BCL2s, and basically they're going to bind to and inhibit this, but also they're going to form a channel themselves in the membrane, and that's going to allow that cytochrome C to be released. So you got a little intro to, oh, you couldn't even see that because I wasn't sharing my screen. Oh, well. Anyway, that's it and that's all. Any other questions?
Yes. Could you explain like what's happening between cyclin E and RB? Because I had messed up that part of the order too for that question.
Okay. Okay, so in that question, cyclin E, yeah, see, let me see if I can find that. Oh, you can't see me. Let me share my screen again. Share. What am I doing? Entire screen. Share. Okay, so let me see. If I go back to exit preview. There's this quiz. Edit. Oh, look at that. There's no image. There's the problem. I know I put it there. Oh, well. Sorry, I'm just kind of figuring out the logistics of this. All right, that's, yeah, okay. All right, let's go back to figures. Where is the one that I used? There was one of these that I changed to make it work better for this question. You can see I reused this question a lot in different contexts. All right, I'm not sure if this is the right one, but oh, shoot. Okay, so here's what was supposed to happen. You were supposed to see, like, instead of letters here, numbers. So you knew what to put where. So 1 would have been RTK, 2 then becomes Grav2, RAS, RAF, MEK, MAP kinase. And you come down in here, and it's, I only left 1 blank here. So what's an immediate early gene? That would be MEK. And then what is a delayed early gene? And I believe that was cyclin D. And then you come out here, and here are the cyclin E, and I had CDK1 here. So that would make it more clear that cyclin E is activating CDK2. And then here you've got RB, which is attached to E2F. So if you saw this figure, it would make a lot more sense that cyclin E and CDK2 are phosphorylating RB. Does that make sense?
And what about CDK4? So could it
Oh.
be 2 or 4?
I think right here was CDK4, one of the delayed genes.
Oh, the delayed. Okay. Okay.
Yeah, because those delayed genes are going to be cyclins, CDKs, and E2F.
Okay.
Yeah, sorry about that. I don't know why the figure didn't attach. I spent a lot of time drawing it. Oh well. Wah, wah. As my 13-year-old daughter says, wah, wah.
Could you share the or add it to Brightspace, that figure, so we could practice labeling?
Sure, absolutely. I'll do that.
Okay.
So
thank
I have a
you.
question going back to that question. The correct
Mhm.
answer had cyclin E last and not RB, but in that image you were saying RB was still last.
Yeah, it depends on how I numbered it. I have to find the original
Oh, okay.
figure, which you saw me going through the. I know it's in
Yeah.
that folder somewhere. I don't know where. Yeah, it made a lot more sense if you saw the figure because it was like a number pointing to the protein, and that kind of made it more obvious. Because if you just go by the order, it gets confusing once you get past IEGs. Okay. Any other questions?
I have a question.
Mm-hmm.
The BCL2, is that anti-apoptotic or pro-apoptotic? And if I can switch between two, how does it do that?
It doesn't switch at all. Basically, BCL2 is anti-apoptotic, as is BCL-XL. They're both sitting in the membrane. Well, it depends on the cell, but they sit in the membrane of the mitochondrion, and they're blocking release of the cytochrome C. So that's your BCL2 and BCLX, and all the other ones are pro-apoptotic. So that's an easy way to remember, because you only have the two that are anti, and all the rest of them are pro.
Are the
And there
pro
are some-
apoptotic, are those like types of BCL2 proteins, or are they a
Yeah.
separate thing altogether?
Yeah, they're types of BCL2 proteins, and we'll get into that in the next chapter, where there are two different classes of pro-apoptotic BCL2 proteins, and it has to do with how they're activated and stuff. So it'll be. I don't want to tell you too much. I don't want to steal my own thunder here, but it's going to be exciting.
Okay.
It's going to be exciting, I promise. What
I have
else?
another question, Dr. Slish.
Sure.
So, in one of the questions, when it basically gave us options between like initiator and executioner caspases. And caspase 7 was mentioned, and I was just wondering, was that one we needed to know? Because I tried to look through my notes to see where it was mentioned, and I don't remember finding it. So I was just curious if that was something we needed to know.
No, that's what we in the biz call a distractor.
Okay.
It's something that's it's just there to make you say, wait, what's 7? I don't know. Now I'm
Okay.
nervous. But if you can see this is the next chapter. There are a lot more caspases. Here's caspase 7. It's an executioner. 6 and 7 are like 3 basically. You don't need to know that for this test, but you can see
Right.
there's a bunch of them that are very specific for like that, for inflammation. And so these we don't get into at all. So
Oh, okay.
yeah. Distractor. That's the one to make you think a little bit. Wait, what? No. All right. Okay, any other questions? I figured this was going to be short. I think this is, I'm a little bit concerned about how much material there is. I think I probably could have done more in this section, but I didn't want to go into cancer biology because that was so much more. But anyway, I'll probably reorder it the next time I do this class if I do it again. But this test shouldn't be too bad because there's really, you know, not that much. Okay, are we all good? Shall we call it a day?
One quick question.
Okay.
I don't know if you mentioned this. So the exam is going to open tomorrow.
Yeah, it opens tomorrow at 8 and it's open till Sunday.
Okay. Thank you.
I like to give people a good window because people have different schedules. They're all over the country, so. Remember the very first exam, I said it will be on this day at this time, and everybody's like, whoa, wait a minute. I hadn't realized just how disparate everybody was. Okay.
I have a request, Whistler.
Okay, sure.
So Sunday is Easter Sunday. I was wondering if we could push the due date to the exam until Monday.
Yeah, I don't see why not. Yeah, I can do that.
Because I'm going home and I'm going to be studying all weekend, but I'm not sure if I'm going to have time to take it on Sunday. So
That's fine. I'll do that.
thank you.
That's not a problem because I probably won't get to grade it until later anyway. I may be going away this weekend. Okay.
Thank you so much.
Sure. All right. Well, I'm going to call it a day then if nobody's got any other questions. We all good? All right. Good luck on the test. We'll see you again next week.
Okay,
Same
thank you.
bat time, same bat station.
Bye, everyone.